Good afternoon, good morning, and good evening. I use this complex greetings to express the global coverage of today's audience. I looked at the registration list quickly and noticed that there are 30 nationalities from 5 continents represented today. My name is Jussi Terho, and I'm the head of oversight of market infrastructure division at the Bank of Finland since October last year. My background is in the operations of payment systems, and it has been very interesting to look at similar topics from a new angle now. However, the target, smooth functioning of the payment systems and the market infrastructure remains the same. At the Bank of Finland, the oversight division is part of the payment systems department, which since the beginning of last year collects the work on both the digital payment infrastructures and the physical cash in one single organizational unit. Developing, maintaining, and using the payment system simulator are tasks that a specialized team in my division take care of. I believe that most of you know our simulator team members Tatu Laine, Kasperi Korpinen, Matti Helqvist, and also Harri Engblom. It is my pleasure to welcome you all to the 18th simulator seminar, which, due to the difficult situation we are all aware of, is organized as an online webinar this year. The physical seminar would have again brought the simulator community together to present latest research, to discuss new ideas, to share knowledge, and to network during the coffee breaks and the traditional evening program at the Bank of Finland's villa. In today's short online event, we will not be able to replicate all those benefits, but I'm convinced that our speakers will present very interesting topics to us. Last week, we had a meeting among colleagues from the Nordic and the Baltic countries. In one of the payments policy-related discussions, one of the colleagues said that we should not miss a good crisis. At first, that sounded like a joke. But I think the point was that when something extraordinary happens, it often opens possibilities for something new. In general, the financial market infrastructures seem to have worked well during the pandemic crisis, as well as they did during the financial crisis 12 years ago. In the current crisis, an example of a change that we have seen is the accelerated pace we are moving from physical cash towards digital payments. In Finland, we just learned yesterday that contactless payments account now for nearly 70% of all card payments. During the COVID-19 crisis, card payments and mobile payments have been increasing, and the usage of cash has been decreasing. Are we facing a permanent or temporary change in payment habits remains to be seen. Let me jump back to the seminar teams. In the past simulator seminars, the presentations have covered topics like liquidity analysis, stress tests, and testing of functionalities changes of the FMIs, and of course many others. Despite the COVID-19, the analysis and research on the financial market infrastructures has naturally continued. Some weeks ago, we reached some of you with a question about what FMI-related questions, analysis, and trends are on your agendas. Topics that were mentioned in several answers and that could be mentioned here were 1. Artificial intelligence. The future role of AI and machine learning is in bank supervision and oversight. New technologies can enable new ways to perform the tasks and ease the operational burden. The second one, new payment methods and innovations. The influence of the new digital payment methods on the traditional financial market infrastructure. There is a lot going on. Instant payments, central bank digital currency, stable coins, crypto assets, just to name some. This year, in the webinar, we have 4 presentations. The first one by Kasperi Korpinen is about the new features of the upcoming simulator release. After Kasperi, it's Sara Testi from the ECB and Marc Glowka from the Deutsche Bundesbank turn to talk about the strengths of the liquidity saving mechanism in Target 2. The third to take the floor is Timothy Aerts from the Dutch central bank, and his presentation is about outlier detection in large value payment systems using neural networks. The last one today is Martin Diehl from the Deutsche Bundesbank, and his topic is programmable money options for central banks. I'm looking forward to hear all of this. Already at this point, I want to thank today's speakers for their efforts in helping us to organize this event. So thank you very much. Traditionally, in the physical simulator seminar in Helsinki, there has been about 50 to 60 participants, which I think is a good number. This year, there are more than 100 registered participants. My interpretation is that even in these difficult times, there is strong interest in the analysis and research on financial market infrastructures. I wish you good and hopefully interactive webinar with interesting presentations. Thank you.
Okay, thank you, Jussi. Then we can move on. I can maybe first introduce myself. My name is Tatu Laine, and like Jussi told you, I'm part of the simulator team. And now in this session, I'm like moderating the speech presentations and also the questions. And before I will give the floor to Kasperi, I will remind you that if you could mute yourself during the presentations and also not to turn off the video link, maybe except the presenters themselves. And then if you have any questions, you use this hand mark in the Teams, or you can also use the chat channel if you have any questions or you want to give any comments. So the idea is now that the presenters, they will have something like 20-25 minutes, and then we have 5 minutes for discussions. And I will be, how to say, very strict that we will follow this 30-minute slot, so we can go through the seminar in 2 hours. Presentations are also recorded, so you can later on look at the whole video, and then if you want to be in the presence of this social media, we have here some Twitter hashtags what you can use to spread these seminar messages. So I will now give the floor to Kasperi. Thank you.
Okay, thank you, Tatu. For those who don't know me neither, I'm Kasperi Korpinen from the Bank of Finland and the simulator team as well. So I will have a presentation on what's new in our simulator, and give you a quick overview on the basic features what are there. So when we talk about a computer software project, we cannot avoid talking about application interfaces, at least nowadays anymore. This is to give an example of the importance of the matter. This is extract from a email that Jeff Bezos, the CEO and founder of Amazon, sent to his staff in 2002. It's called the Amazon API mandate. Quickly said, the main message here is that he wanted that every team, every service, software service inside the organization will communicate between each other through APIs, so that this software will open themselves to other softwares, allowing for their interaction smoothly and efficiently. This is a very important feature or way of designing software ecosystem in an organization. What is fun is actually you can try to think of your own organizations, to which extent governments and central banks, for example, put these principles into practice. So if you look at the point 6, you can definitely see that Jeff Bezos thought that this is a very important point. And it is also said that part of the success of Amazon is based on this Amazon API mandate. So what does this mean on the level of the simulator? Is that our new architecture looks like this. So on the left side, we have the client layer, and we have created the new user interface as a web application, single page web application. On the simulator engine side, we have this control layer, which acts as a front application interface layer. So every communication will go through this layer, and the protocol used between is HTTP. So in common words, this means it's a web application. So you can deploy the simulator on servers if you want, but still you can deploy them on your laptops or desktops, and you will access it through web requests, HTTP with a browser or something. What is great in this approach is that you can create or build even competing graphical user interfaces using web technologies if you want to. You don't have to, because you can actually use the HTTP protocol or a web layer to access the control layer or the simulator, also from R, Python, whatever tool that supports HTTP protocol or standards in that sense. Ideally, the situation would be such that users will not have a need to access the database in the future directly. But okay, that might not be reality in all the cases, but ideally, if there will be such a need, we should develop on the application interface a way to request data from the simulator in an efficient way and in a way that will serve users better, even though they are not, for example, using our developed user interface. This gives flexibility in the way of deploying the software. So as I said, we can deploy it on a VPC, virtual PC, or we can deploy it on a desktop, just like now. But we can also deploy it in a way that the simulator is installed on a server or in clouds. Behind the databases can also be installed on a different environment if wanted, but all this has to be evaluated in a case by case whether it's required or intelligent or in any way. Yeah. Okay, so let's go and have a look at the simulator itself. And it looks like this. So there is a server behind that runs the simulator, and we access it with this HTTP request. So you can just, for example, open a new browser sheet. You just make the HTTP call, and it opens you the user interface. So I have it open here. There are big changes in the graphical user interface. Basically, still the same functionalities as before are there. Let's say 95% or something like that. But the biggest change is that we have consolidated the views. So we had like 10 views in the old simulator. So now we have only 3. And we have condensed a lot of things in one view, especially the project one. So the idea is to get a more faster and more easily an overview of a situation awareness of what's there, like what projects are there. So these are projects. You can hide them if you want. We will be looking now at Demo 2 first. So what is inside Demo 2? There is one simulation defined here. And you have import data in relation, which is here. So these are the import data sets for those who know. I have already imported a lot of stuff here, but we can have an example. So if I want to add a new participant data set, I will do it this way. So I go and select quickly a file. So this is just to get the idea how it works now. What is the logics behind? And I select an input template, the demo. I give it some kind of name, whatever. And what is actually new here is that now the tool reads already a few lines from the file to be imported. So the 1, 2, they are actually values in the file. So you can directly check that what is there. And it's giving you also the possibility to see that what kind of fields you can import there. So this is makes it a bit easier to import new types of files. But usually, of course, when you know what you're importing, then you don't need to do anything there. I don't need to import this one now, so I'll skip it. So let's see. I have defined here a simulation, so we can go and see what is it exactly. You see, you have here you have the system data sets that we have selected and the output statistics here. Some of these features will still change, yes. So this is, to be frank, it's still a work in progress, but this gives already an idea of the direction where we are going. Maybe it's worth also having quickly a look on the system setup here, so to see how you select the algorithms nowadays and define the time. So here, for example, you have new types of controls to define the time, so you maybe make hopefully less mistakes when you input the time things. Here to select the algorithms, you just drag them, drop them in the right areas. So you have the entry algorithms here and settlement algorithms and end algorithms, for example. So to run the simulation, you just click here. So you see it's starting the job behind on the server. The server is local here. Here you get feedback that's okay, it's a success. If you want, you can go and have a look here. These the logs, actually, that's what is happening in the simulator. What you have done, it's logging the events and reporting also the status of it, and it's giving you also some kind of report on that. It depends on the task you have run before, so you can see really what was there. So it ran the simulation. It took 4 seconds. It was a success. Okay. Let's go back here. So we also have taken few steps on the reporting side. So the one reason why we choose the web technology was also that we were able to leverage more easily on JavaScript reporting libraries. And currently we have used D3 as an experiment. So the simulator has been run. So now through this icon, we can go and get some basic statistics out of it. So we get these rudimentary pictures here, but it's fairly easy. So our feeling is very prominent that we can do a lot of interesting stuff. So by clicking, we can dig in to get account level stuff. The other one was system level stuff. So here we have accounts and volumes or related volumes. Yes. We can select date if you want to look at one day or something. We can just make quickly the selection there. We can focus on one account, and we get the same information for one account on every day pretty fast. And I guess that this can definitely be improved further. And yeah. Then we have one example of also the types of pictures we can do with D3, and there are a lot of other, if you look in the internet, that what kind of interactive graphs you can do with D3, for example. Very interesting stuff, and takes time to investigate them. But here's an interesting example. For example, two graphs are communicating with each other. You select an account here, and you will see on the left side, you can see the dots, which will highlight at the same time on the other side. So this to get some idea of the liquidity timing type of behavior of a certain account. So if you go here, you will see that this participant is sending payments a bit later and using a bit less liquidity. So it could be some kind of free rider type of behavior. And if you go on this extent, you will see that the participant is kind of sending payments a bit earlier and using more liquidity. Yeah, just to give the idea. Yeah, so we have added few new features. So for example, you can quickly download the data set you used as an import. Of course, it cannot be a big data set, otherwise Excel will suffocate it. They come as a CSVs, yes. So So you can get a bit quicker access to the data which is behind. Traditionally, you remember those who have used the simulator have the account statistics system level and transaction level statistics, so you can quickly take downloads the same way just by clicking the icon and you get the stuff out. Okay, so I guess this gives you already pretty good overview of the new simulator, how it looks like. I will actually take another project just in case I will not make an error there. Let's go, for example, here on the stress project here. So I quickly show you a little bit how the stress tester looks like in the new world. There are no major changes here in that sense. So we have been focusing on moving the old functionality and trying to get rid of redundant stuff and adding maybe some new enhancements. But this is going to leave further, and changes will still come. So, but you get the main point anyway. So this is an analysis I have defined already before. So I called it stress 2. You can select the way the scenarios will be created. So this creates scenarios automatically. So if I select the rule by participant, it will create the stress test scenarios by participants. I can select here just by dragging and dropping the accounts to be affected. I have also a filtering possibility here if I want to use, if there are more accounts. And here is the very important clue. Here is the SQL filter to be used to create the scenarios. So here I have a default filter. I can just get it down and we can have a look at it. So the filter is a SQL sentence that will affect. It knows this requires some skills, but we can provide help for that too. But you can affect the way the scenarios are created by modifying this SQL, and you have some reserved words like in between them. But you can modify these and save them with a new name, and you can upload them and they become available here. Okay, I get out. So if you run it here, it will create the scenarios for the free accounts I chose or participants. There is one account for one participant. Here you can follow the progress and you'll get feedback slowly after when they are getting ready. So here you can, on the tasks, you can always go and check a little bit how it's going also. So the stress tester was run, you see a little bit when it was started, when it was completed, and so on. Yeah, so here is another feature you can use. The auto import, for example, I just select this one here for simplicity. I can select the files all in one bunch. If I don't want to import them one by one, I can take them all here. And I have already actually these templates already selected correctly. If I want to skip some of days, I can do that. I can select days to be skipped that I don't want to import, and I can store them in a file. So I can have this definition also for days to be skipped in the file. I can upload them or download them and modify. So this is all OK, no worries. Now I want to import them with another name, so I will put raw2 and run the import. So we can follow the progress here. Okay, there is some issue coming there. I don't know exactly, or maybe it's still running. But anyway, yeah, it didn't. Maybe some template was wrongly chosen or something, but it doesn't matter now here. So if we get out of the simulator user interface that we are providing, so to give a little bit of an example of the possibilities of using the simulator from third-party tools, there is this possibility that, for example, as all the communications go through these HTTP requests, so just like in the web world, you can build standalone static index HTML pages, for example. If I look at this one, the index .html. It's a D-free code. So it's taking a D-free library. We have nothing to do with it. It's not our code. We just took it. We made some modifications to direct it, but the key is here. So D-free gets a JSON file. So JSON files are a certain format that is very common to be used in association with web programs and so on. You give here the HTTP call. So this call is a GET call that will return the account statistic data in JSON format for the project demo 1 and from the simulation 1. So if I take, for example, a copy paste from this code, I can put it directly in the browser. It's a bit technical, so sorry for those that this is not so natural, but this is the data it's getting. So with this call, you can get this data. But if you want to get it into your D3, so you had the code there, you can just simply open this one and you get the data. And it draws you this picture. So this is the same data as you see here, but it's directed with this HTTP call and the JavaScript code. It's directed directly to this D3 module. So you could combine, work the same way from R, Stata, or any other third-party tool that supports this type of HTTP connectivity. And I think this is growing and getting quite normal already in the world. I think Excel's business, what was it called? The business tool, this Power BI also supports this kind of approaches nowadays, at least if I remember correctly. Yeah, I guess I'm getting there. So this gives you an idea of the capabilities of the new simulator. So I think I will stop presenting now and leave the floor to some possible questions. Yeah. So Tatu, are you?
Yes, I will continue from here. So now there is time for questions for Kasperi. Like Kasperi presented us this new user interface, and like we see that there is so big change that we are planning to call it PSS3 instead of PSS2. And now, if you like any ideas how you would like to develop it further, you can contact us bilaterally or in this chat, or if you want to be like a pilot users, then you can also call to us, and we are happy to share with you, I mean, the new user interface.
Okay, I see there are hands raised. So yes, okay. Jonna, maybe you can start. I saw you first, or Jonna, can you unmute yourself and?
Yes, I'm here. Thank you. Thank you for the presentation, but I only have one question. I don't know whether it is good or a bad one, but I would like to ask it anyway. You showed us two diagrams, which they had like spots, and the other one was vertical. No, it was. Can you please like go back?
Yeah.
The
yeah,
slides?
I can. Yeah. It was not slides. It was the tool itself. Yes.
Okay. But you talked about participants, like the some of the participants had more like frequent payments, and do you know what I'm talking about?
Let me see.
I was just wondering because you were talking about participants. That what are the participants?
This one?
Yeah, that one. That one. Exactly.
Banks. So it will be banks that are settling payments in the payment system.
Okay, that's what I thought. Okay, thank you for the clarification.
Yeah. So some other questions. Let me go down the line. Maybe Shukri Driss, you could.
Yes. Hello.
Hello.
Hello, Kasperi. Hello, Kasperi. How do you do? Hello, everyone.
Thank you.
Hello. Hello, Tatu. Hello, everyone. My question is about. Of course, Central Bank of Morocco is very interesting to be in pilot of this new version, PSS3. My question is about the organization of the training of the new version. Do you plan to do this in next year if the pandemic is stopped? We hope, hopefully.
Yes, we have been thinking about it, and we are most likely organizing it as a webinar. So if the situation continues like it is now, we might well have the next training as a webinar. Yes, but we don't have any date yet fixed for it. Once we survive this webinar, which is the first one for us, then we will start planning possibly for the next training webinar. Yeah.
Thank you, Kasperi. Thank you.
So then there is a Thomas Nilsson. Maybe you could take the voice. Or...
Yes, hello, Kasperi. Can you hear me?
Yes, I can. Yeah.
Great. Thank you. Thank you so much for this presentation. I continue to be impressed with the work that you're doing with this simulator. I can only imagine what of a burden, but a good burden it is to develop this new version. So first of all, my question is, where is in the user interface, where is the picture of the Bank of Finland? I couldn't seem to see it anywhere.
In the user interface, or
yeah, I missed the picture of the Bank of Finland from the previous version.
Okay. Yeah, it has been like we have the lion of the Finland or Bank of Finland, which is behind there.
Yeah, the background. Okay, well,
yes,
I missed the nice picture. Anyways, that was more of a joke. My question is, so will you continue to support PSS2 after you release PSS3?
Well, we haven't been asked this question before, so of course not actively, not in a way that we will not keep developing it, but for some, let's say we strongly encourage migrating to this new one, and I think it might. It depends. Maybe if you have some specific issues, we could maybe have a bilateral meeting or something like that, and discuss the case if you have some concerns or something. But conceptually, I would say the migration is not a very hard step to understand, because you can find a lot of same things there, but they just look a little bit different. But if you are a heavy user of the command line interface, then there will be a lot of changes. It might be painful first, but if after the first effect, you most likely will be pleased. And using the HTTP application interface, the controller layer, so-called, it's taking the place of the CLI. So this is a great thing in the sense that we don't need to upkeep a CLI separately anymore. And at the same time, users will be using exactly the same functions and functionalities that we are using through the user interface. One benefit more is that because we have made this as a web application, and there is this control layer there. Let me take the PowerPoint presentations out. One of the great things actually is that in this control layer, as we don't know who is contacting it, who is asking the questions, asking for data or something like that. We don't know which program is doing it. We are agnostic in the simulator. And this is a big change. And this also changes the way we design the control layer, because it must be able precisely to anticipate that the request can come from anywhere. It can be faulty, it can be correct. So it means we have to build here like parameter validation checks. So this means that this layer and these modules, functions, methods that you call, they're all much more robust than they were before. They have to be. We have to check whether all the parameters you give there, if you say that add me a new project, define me a new simulation, import me this file from there. If you give it this kind of orders, like from R or some other tool, we have to somehow take control of that and check that these requests are correct, formally correct, and make sense. And also we need to check
Kasperi,
that the database is in order. Yes. Okay.
Sorry to interrupt you, but we should now move
indeed.
on to next presentation.
Yeah. Okay.
Yeah.
But
Thank you,
thanks,
Kasperi.
guys. Yeah, thank you.
So I will open the PowerPoint presentation again. It will take some time, and then we can move on. Okay, so now we are back in this presentation, and we had Kasperi's part. And then the next presentation is by ECP strengths of liquidity system mechanism in target 2, and it was Sara, Testi, and Marc Glowka who are going to present this presentation. So please, maybe Sara, you can take the control, and you maybe know when Marc is going to continue. Sara, you could unmute yourself so we can hear you.
Okay.
Okay, now we can hear.
Okay, great. Thanks, Tatu. Marc will be starting the presentation now, and then I will concluding it. So I would say that he takes the control first.
Yes, but we do not see yet Marc, I mean, among seminar participants. I don't know what had happened to him.
How we got the time? Okay.
So maybe you can start.
Okay. Fine. No, not that he got the timing wrong. I'm not sure. Okay.
No, it seems that he just joined. I think.
Just joined. Okay.
Okay.
If you, I'm about to let him in, and we just need to grant some access rights, and then he's good to go.
Okay. Thanks. So that's maybe if it's okay that we wait a couple of minutes, then we will try to recover that during the presentation.
Hey, I'm there now. Sorry for the delay, but there are different time zones, and I was a little bit confused when the conference is starting and when not.
Yeah,
sorry.
But you just arrived in time.
Okay.
It's your turn now, so you can take the control and continue this seminar. And I give one advice that when you stop it, don't click this stop presentation button. So I will take the control back to Helsinki. So please,
okay.
Floor is yours.
Okay, so welcome to the 18th settlement system simulator, and many thanks for the organizers that they managed to also that the seminar takes place this year again. And I think it's the first time that this seminar is taking place via a video conference. And yeah, I think everybody of us has now participated in several video conferences, but for me this is a special thing because yeah, for 3 years now I went to the seminar, and this was a little bit the highlight of the late summer, also with the sauna and the Baltic Sea. So yeah, I hope next year we could see us again and do not have an online conference. Nevertheless, I'm very happy to present now with my colleague Sara from the ECB the analysis of the target analytics group about the strengths of liquidity saving mechanisms in target 2. Yeah, so okay. So as usual, this is a typical disclaimer. So we only will present our ideas and opinion, and this is not necessarily them of the Eurosystem or ECB or Bundesbank. Also, this study has been done with several colleagues from other national banks and also from the ECB. So also with Kasperi from Bank of Finland. Yeah, so a short outline. So I will start to give you a short background and motivation of the study, and then I explain you a little bit the methodology of our analysis, and then I will give the presentation to Sara, which will show you the results of the study, and also give a short conclusion at the end of the seminar. Yeah, background. So why do we did this study? First of all, liquidity optimization mechanisms were introduced in RTGS long ago, and then they support in general effective liquidity usage by participants. And so target 2 has 2 different liquidity management tools. So one more or less for customers. So there are several liquidity management features that will be described in some seconds. And the other ones are like system built-in instruments that are liquidity saving mechanisms. And so the target 2 operator revises the function and its usage for their compliance against the PFI, for instance, but also to know how much liquidity was used and how the system was operated. And but yeah, in the last time there were not so big analysis how the liquidity optimization mechanism were used or how they're functioning, because like this was be for granted that they are in the system. So there are no questions about to set off some algorithms or to move them. So there's a clear preference that they are there and they should be there. So here the target 2 offers different liquidity saving management tools. So this is to help to participants to optimize their liquidity usage. And so these are, for instance, priorities, reservations, limits, time payments, liquidity pooling between different participants in the same group, and of course an active queue management, so they could change the priorities or the place in the queue by their own. And so with this, target 2 help to reduce the liquidity risks and have and mitigate the counterparty and operational risks. So on the other hand, these are the liquidity saving mechanisms that are built in the source code of target 2. So this is first of all the entry of setting algorithm, then the introduction of the queues, and then also some optimization algorithms that are in place. For instance, the all or nothing algorithm, the partial optimization and the multiple optimization. So with the more or less introduction of the multiple optimization, the first all or nothing optimization was switched off in 2009. And also there are two partial optimization, there are two algorithms for the handling of ancillary system transaction. So this is the algo 4 and the algo 5. These are the algorithms that handle the queue management automatically by the system. And previous studies, not also for target 2, but also for other payment systems, are focused mainly on liquidity saving features and in analyzing the welfare effects of introducing some or one liquidity saving mechanisms in an economic model. Our focus is a simulation study, which used the payment system simulator of the Bank of Finland for analyzing the implements or the benefits from these queuing algorithm and optimization algorithms. So this was also the motivation of our study. Is first of all that we want to quantify the benefits that the liquidity saving mechanisms are bringing the participant when they are into account. And with this, we could provide insights of the function and efficiency of the settlement in target 2. Also, it's relevant for the compliance with the PFMI and SIPS regulations. Furthermore, it's gain an understanding of the effective of LSM, and also provide some lessons learned for the design of the functionalities of the future target services. And also in this regard, it's important, like, bring light into the discussion if instant payments, whether instant payment systems could replace RTGS or not. So the methodology is mainly based on a previous study that we presented, or also Olivia and Alexander, I think, presented last year in Helsinki. So at this study, we used the simulator from the Bank of Finland to simulate and pure RTGS with an instant payment is more or less, with customer payments from target 2 below 50,000 euros in different scenarios, and wanted to understand what are the liquidity implications if you move these transactions to an instant payment system and not to an RTGS. Also, the Bank of Finland simulator give us the possibility to create different scenarios where we remove or progressively reintroduce different offsetting and queue algorithms. And in the end, we wanted, or we will compare the end of day settlement levels in the different scenarios with the one with the benchmark scenario, benchmark simulation scenario, where we simulate the days with the normal target 2 parameters. So in the next slide, there's an overview over the different scenarios. So we have 4, and like in the first scenario, we have more or less a plain RTGS setup. And you see here that we use some basic algorithms that are necessary to handle the introduction of payments and also the settlement of ancillary systems the transaction of ancillary systems. So here especially you see the algo 4 and 5. So in every transaction we use the algorithms for ancillary system settlement, and into the next in every scenario we add more algorithms that are in place for the handling of target 2 payments. I think there is a question. Yeah, so.
But Marc, maybe we will continue first the presentation, and then at the end we can ask the question.
Yeah. Okay, so I will go on. So without the algo 4 and 5 in every transaction, every ancillary system transaction will be not settled and fail. So this would, so they are necessary to put into account. And also in the end, we compare each scenario with the benchmark scenario to evaluate how much liquidity was saved when adding a new algorithm or another liquidity saving mechanism. Yeah, so in the end, we have data input from different years. So we took into account 2 weeks over different years with a little bit different liquidity levels in target 2. So from 2040 to 2019, we simulate 2 weeks, the same weeks every year. We take into account no behavioral changes on the side of participants. So if you could imagine, if you really change the setting of target 2, the participants will behave different, but we exclude this from our analysis. And also overnight deposits are excluded from the simulation output, because like this is in part they are taken in the end to bring some liquidity to central banks or from central banks, and also some transactions that are unsettled in the benchmark scenario are settled in the scenario. So this is due to the technical limitations of the simulator or liquidity available in the accounts, but we could not distinguish between these 2 effects. Yeah, but we take into account all data that is settled in target 2, and yeah, so we hope that our results are as near on the operational point of view as it's possible. So now I will hand over to Sara. So Tatu, I have to click on presentation.
No, I take the control then.
No.
Okay.
No, Sara will take the control.
Okay.
Okay. Let's see if it works now. Yes. Okay. So, so thanks a lot, Marc, for this overview of the purpose and the methodology of the study. As Marc mentioned, I will guide you through some of the main results of the study, and then conclude on the outcome of the study. So the objective of the study, as Marc mentioned, was to estimate how much the presence of LSM improved the settlement performance in target 2. So with this first indicator, we show you how much the share of unsettled transactions increased in the scenarios compared to the benchmark simulations. What does it mean? What does it mean? That what you can see in these bars is how much the I'm sorry, I hear some typing in the background. If you can also mute your phone, thanks. Thanks. Sorry. So what these bars show, it's how much let's say how many unsettled transactions in percentage of total transactions are created in the different scenarios where we apply the constraints that Marc illustrated before. These are shown as difference from the benchmark. As he mentioned, the benchmark it's a simulation where we simulate the normal target 2 setup. and then we go to see how much these unsettled transactions increase in the scenario. So how many more unsettled payments there are when we move away from the normal target to set up and we apply the constraints. So what this chart shows is that so in almost all years, the most severe scenario, so the one where we apply most of the constraints, scenario 1, that it's closer to the RTGS setup, leads to the worst results in terms of unsettled transactions. This is shown in value. So how much in terms of turnover? So what's the deterioration of settlement in terms of turnover? And what we can see is that as the system becomes closer to the target to set up, so when we reintroduce algorithms, so with scenario 2, scenario 3, and scenario 4, then results improve and the level of unsettled transaction decreases. So this is true for most years and most scenarios. There is in particular this effect that you clearly notice in 2018. Before it was already mentioned that we have this effect where in some years and for some scenarios there are some transactions that remain unsettled in the benchmark that are then settled in the scenario. Since this is not clear whether this is due to some technical configurations of the simulator, so some small discrepancies compared to the live system, or to additional liquidity available, we left this phenomenon in. We didn't correct for this phenomenon, and this is in particularly the case for 2018. So looking more like at the value, so how much there's really like these transactions, the unsettled transactions increase in the scenarios, you can see that in most of the years, so excluding 2018, the unsettled payments increase between 18% and 0.18% and 0.57%. Of total transactions, and this corresponds to an average of 10.5 billions over the period for scenario 1. So in the worst case scenario. Now I would like to show you a similar picture for the volume, so for the number of transactions. So it's a chart similar to the previous one, but here we focus on the number of transactions, and what we can see is that the deterioration of settlement levels in value in volume terms it's much more consistent with the severity of the scenario. So the deterioration of settlement is more in line with the constraints imposed, with of course scenario 1, so pure RTGS, leading to the most severe results. Here we are in the range of deterioration of between 0.35% and 0.59% increase in unsettled transactions, which correspond to an average of 1.7 thousand transactions, so 1,700 transactions. What I would like also to mention is that the number of participants affected is quite low. There are a few participants on average around on average 20 per year that are affected. Some of these are also participants which settle high share of the traffic, but overall the impact is quite limited. Of course, participants benefit of quite high liquidity level in their accounts nowadays. So this chart here focuses on the impact of each individual algorithm on settlement. Basically, this is constructed as a difference between the different scenarios to isolate the impact of each LSM on target to settlement. So basically, the blue lines, the blue bars, what are called multilateral offsetting. Actually, there's a mistake here. They should have been called bilateral and multilateral offsetting. Represent the difference in increase of unsettled transactions between scenario 2 and scenario 1. Like that, we isolate the effect of the reintroduction of the bilateral and multilateral offsetting, and so on and so forth. So they are constructed as a difference between the different scenarios to see what is the impact of the reintroduction of which algorithm on settlement. So how much settlement improves in terms of decrease in unsettled transactions. So what this chart shows clearly is that in terms of efficiency, the offsetting so the algorithms for offsetting and the algorithm for multiple optimization are more effective in improving the settlement. And this is true both for the value and for the volume of payment, so left-hand side and right-hand side. From a value perspective, this improvement...
Okay, Sara,
yeah.
You have still five minutes just to remind you, so...
Okay,
yeah.
This improve. Okay, fine. So what I wanted to say is that in value terms, this improvement it's more in line also with the liquidity levels in the account of the participants. So as liquidity increased in target 2, the impact, the marginal improvement is lower, whereas in volume this seems not to be very consistent with the liquidity levels. So another aspect that we looked at in the study is the queues. So as we know, algorithms are not just meant to improve settlement as such, but also to let's say make it more efficient by increasing the settlement speed and reducing the queuing time. So with this indicator, we show what is the impact on queuing times in the different scenarios. This indicator here, it's not presented as a difference from the benchmark, but the benchmark it's presented separately. So what we can see here is that so the box plots present the distribution of the daily average for the queue for interbank and customer payments. So we focus only on this category of payments because for ancillary system payments, queuing is not so relevant as they settle in a bit different way technically. So what we can see is that the median time of settlement increases, especially in scenario 1, and improves compared to the benchmark, and improves as we reintroduce payments. And the differences are quite consistent with the severity of the scenario. This chart here instead shows the changes in the queuing time compared to the benchmark for individual transactions. So it's a distribution across scenarios of the change in queuing times using kernel densities. So what this shows here, what we want to show with that, looking at individual transactions, this is then the difference from the benchmark is that so most of the payments do not queue longer in the scenarios, so the distribution is very centered around 0. However, there are very, very small difference in queuing times for the payments. However, there are some very extreme values, so some payments they queue much, much longer, or also some payments also improve their queuing time in the scenarios, and this could be also driven by this phenomenon that we say that some transactions change settlement status then in the benchmark. A last chart that I would like to show you, it's another phenomenon we looked at. So the fact that some algorithms, when they are when some constraints are imposed, so some algorithms are switched off, the remaining algorithm improves their efficiency. So basically, what the left chart shows you are the transactions in scenario 1 for 2019. So this shows you that there were few unsettled transactions. Most of the transactions were settled, and some transactions for a value of around 80 billion were settled using a different algorithms. And then the right chart shows you how these settled transactions, so we do not speak about unsettled, but settled, are settled using a different algorithm in the scenario. So it looks like once you switch off some of the algorithms. Some transactions are settled through a different algorithm, so these algorithms become more efficient. And for example, in scenario 1, we can see that algorithm 4 and the entry algorithm settles much more, so they improve their efficiency and settle more transactions. So that was it for the overview that I wanted to give you of the results of the study. It's a partial overview, but these are the main indicators. So we started with the objective to show how much the presence of LSM improves the settlement performance in target 2. We can say that all in all, this study confirmed that the LSM in target 2 support the efficient use of liquidity and improve the settlement performance in the system. And we can see that across all years and most of the scenarios, the settlement deteriorates once we move away from settlement levels deteriorate once we move away from a target 2 setup to move towards a pure, what we can call a pure RTGS system. We also saw that bilateral and multilateral offsetting and multiple optimizations were more efficient, were more effective in improving settlement compared to the partial optimization. We have also some positive effects on queuing time of the introduction of algorithms, and results show that queuing times improve, so the speed of settlement also improves when algorithms are active in the system setup. And another phenomenon that we looked at is that the settlement efficiency of the remaining algorithms. So once you change the setup and you switch off some of the algorithms, the other ones work better, improve their settlement efficiency.
Okay, thank you, Sara. Or have you still one slide? Or
this is the very last one. It's the very last.
Okay.
While it's clear, while it's clear that the settlement efficiency improved in target, we also saw that the effect is quite limited because it remains in a range that it's below 1%. This, of course, we have to take into consideration the fact that these LSM settle on a very small share of target payments. They settle well below 10% of target payments. We analyzed only few algorithms, not all of them, and so these algorithms analyzed only a subset of the target 2 transactions, and in general, liquidity levels are very high nowadays. Nevertheless, the algorithms are efficient, also in presence of high liquidity level, and therefore we can say that also they represent an important buffer in the future in case of changed liquidity conditions. We expect that they will work more, and they will have to improve settlement. And with that, I would like to conclude and open the floor for questions. Thank you very much.
Yeah, thank you, Sara. And now I will take the control back to Helsinki. Don't click any button. So, but now we can have a time for 1 or 2 quick questions if the webinar audience has any. So please raise the hand or use the chat if you want to ask a question. Any questions or comments? Okay, there is. Let me see. So, Tris, you can unmute yourself and ask a question.
Thank you, Tatu. Just one for my understanding, because we use the old version, PSS2. My question is about the algorithm that Sara presented to us. For example, T2 entry, is this algorithm are dedicated to target 2, or maybe we can find them in our release on our version?
So what we use?
Sara, you can answer.
Okay, so what we use for the study, it's the what we call the target 2 simulator. It's a version of the simulator that is adapted to the target 2 settlement logics. So okay. The entry algorithm, it's a basic algorithm. It's the entry algorithm, so the one that settles the payments at entry. So I think, I mean, it's called T2 entry because it's for target 2, but I presume that it's a similar logic. It applies a similar logic to other RTGS.
Thank you, Sara. Thank you.
And how about Matti, if you want to ask one quick question?
Okay, thanks. So thanks a lot for a very well conducted study. It's interesting. I was wondering, you raised also to the conclusions that it seems that the bilateral and multilateral offsettings are more effective. And I wonder if that is largely driven by the setup where you first include the bilateral offsetting algorithms and only after that give the floor and possibility for the multilateral or partial netting algorithms. So it could change the conclusion, or I think that the conclusion might be driven by the test setup in this way. So have you considered changing, or is it possible to change the order there?
That's the thing. So the thing is that we made a reflection also together with Kasperi on technically what was possible to apply in terms of change setup with the simulator. And we seem to understand there is also a kind of sequential logic that as to which the algorithms have to be applied. That is why we decided to do this progressive reintroduction and then keep on the ones that we had so the algorithms that we were reapplying. So for example, the case of the bilateral offsetting, because we weren't sure whether it would work without, whether it would be possible, for example, to have the optimization without the offsetting. This did not seem to be possible from the logic. In any case, what we do, for example, we apply separately the optimization once. We first apply the partial optimization and then we apply the multilateral optimization. And between the two, there's a big difference in performance. So multilateral works well, partial, it's a bit weaker. So I think already between comparing these two, other things unchanged, I think we can draw some conclusions on that, and that's why the conclusion on the multilateral.
Okay, that's very interesting. Just a comment and mention that it would be highly interesting also to see the results with the lower liquidity levels. Now you were having very high liquidity, but that's a comment for future work.
Yeah, but nevertheless, in the study we have very different. We have 200 billions in 2014 and 8.8 trillion in 2018. So we have 2019. So we have a quite broad range of liquidity levels.
Okay, so I thank you, Sara, you and also Marc for this very interesting presentation. And now we will move on to next presentation. And let's, I will find the cover slide. So the presentation comes from the Netherlands Bank, and the title is Outlier Detection in Large Value Payment System Using Neural Networks. Does including memory improve the performance? And instead of Ronald, Timothy, you are going to present it, and I now tell you this online that I copied your PDF to this PowerPoint presentation, and you just take, like Sara and Marc, you just take the control and then you can scroll the slides. So floor is yours, Timothy.
Let me test if it works. Oh. Nice. Can you hear me? First of all?
Yes.
Okay, sorry, it's a last minute switch. I'm testing my setup as we speak. I also have to apologize. My home computer does not have a camera, so I'm going to be without images. Yeah, and then first of all, thank you to the Bank of Finland for again organizing this seminar and this meetup. And I apologize that you will have to do with me instead of Ronald. But yeah, it is what it is. So onto the project. It builds upon the papers previously done by Ronald with autoencoders in large value payment transactions. And this is cooperation between the Nederlandse Bank and the Bank of Canada. So the idea is that we will do the same algorithm on our data and on their data. I should have skipped to the first slide. Let's see, the general outline. First, I'll give a motivation on why we're doing this, then a research question, show you the analysis, and our final remarks. A side remark is that this is definitely work in progress, yeah, it's still an active project. So first of all, the motivation. I think everyone is aware that the real-time monitoring desire is great within the financial industry and with regulators, so that this ties into that. And every crisis, yeah, it would be nice if people would actually be able to predict this. So what the idea is that we will try to predict bank runs before they would even happen, or at least pick them up in an early stage, so that still actions can be taken. Well, so then the question becomes, can we do something with machine learning in these large value payment systems? The problem with the data is, of course, that it's unlabeled, so there's no training set readily available, so we have to find other ways. And we don't have any known outliers in the dataset present. I think in the Dutch case, we might have one instance which could resemble to one of these bank run outliers. So we have to come up with different solutions to test the algorithms, basically. And that we are doing with augmentation of data. So we're basically creating bank runs off of existing data and seeing if our autoencoders pick them up. And we're really detecting and not predicting the next steps. So then we come to the research question. Do memory-enabled neural networks have enhanced efficiency in detecting liquidity problems? This builds further, as I said, on the paper that Ronald did with Ron Trippels and Leonard Sabetti, which was the paper that was presented last year. And we basically add to those two methods one simple thing. We use the typical autoencoder, which is also presented in the papers, where you have an input layer, a hidden layer, and an output layer. So this algorithm basically tries to reconstruct the data it is given. It compresses and decompresses. In the compression stage, you would expect the algorithm to pick up the relevant features so that it can recreate the same output. Later on, we will use the compressed representation of the data to do some analytics. But a regular autoencoder is only able to take a snapshot of the current state. You feed in a state and it will have to recreate this state. And it views it as a whole. But you could view all of the payment flows as a time series, where there might be a complex underlying relationship. So this is why the idea was proposed to include memory layers inside of as addition to the autoencoder. So how does it work? We train it on the raw data, hopefully without any outliers, because it would also learn how to represent those then. We evaluate it on our scenario augmented data, and then we use two methods to evaluate the performance. And oh, it's still at the outline figure. I'm at how does it work? Oh. I'm not sure if everyone is at the same slide. I also see nothing else.
Slide. How does it work?
Yeah, there are some people in the chat are saying that the slides are frozen.
Yes, that there is this kind of eye next to this take control, and you should like cross the eye, then everybody is on the same slide. So it can be that, I mean, if the people do not know that if they are scrolling the slides, I mean, they are in different slides, but just move on.
I'll continue. Okay, so in evaluation, we use two metrics. in Ronald's previous research, along with Leonard and Ron, there was the reconstruction error used. So they would feed in an augmented scenario, let the autoencoder compress and decompress, and use the decompressed version and compute the mean squared error between the original and the decompressed version. So we will use the same method, but in addition to that, we will start comparing latent space distance. The idea is that the latent space, so the middle layer, will be a compressed version with only relevant features of the input data. So if we use a distance metric, we would expect, or we hope, that outliers will have a large distance when compared to the center of the regular data. So we will simply use Euclidean distance on this latent space. So in a test version, we have the latent space is 16 dimensions. We have some limitations, of course, in the regular autoencoder, but I've already went through this. My apologies for the bad ordering in my presentation. So here we have memory as a solution. The idea is that we will start creating sliding windows on top of the data, which could overlap or not. We are not sure yet about this. We're testing different setups. And then we're using GRU gates and LSTM gates. So GRU is gated rectified unit, and LSTM is a long short-term memory gates. This changes the way we will feed data to the algorithm. In the settings which were used in the previous paper, there was a bilateral flow matrix, and they would aggregate between 5 and 60 minutes. We are reducing the time frame. We are going basically considering tick data and 60-minute aggregates and everything in between. The bilateral flow matrix is simply all the banks on both axes and an aggregate within the time frame of what amount of value they have transferred. In tick data, this will be simply one payment. The memory version of this will not have one static version of this aggregate, but it will have several of these aggregates or several of the payments as a time series input. Oh. So then the scenarios, how are we going to estimate whether or not we actually can achieve what we set out to achieve? We augment known transactions. So we have a scenario class built which takes a regular transaction and slowly builds up a bank run. This is done by a parameterized exponential growing function. So we can also test whether or not our algorithm eventually will be able to detect different growth rates in the bank run. And we have some more settings which are displayed here. I think especially the parameterization could prove to be nice because we can quantify what type of bank run could be detected if a bank run is an exponential growing function. Challenges? Well, cloud computing is a very difficult topic within the central bank. DNB is currently moving towards a full cloud data science platform. We were supposed to have the initial setup for this project in March, but we have only started like 4 or 5 weeks ago. So we've been racing to get some results to present to you. Then again, in the data issues, there's very few historical examples of these liquidity set issues. And there's a massive variety in options of the issues. So even our scenario generator, it's just one of the potential liquidity issues. There is some decent news though to report. So we've retrained the same autoencoder used in the previous papers which are mentioned, and we have started training our LSTM autoencoder. And actually the algorithms are learning. Whether or not we are happy with what they're learning is up for debate. But what you can see, I think, is decently interesting here is this is a T-SNE representation of the latent space vectors. So what you see is that given the input of these bilateral flows and the features of them, The compressed version, actually, when you plot it on a 2D scale, it shows some grouping and clustering. So here we do days of the month, right? So payments between 1 and 31. And you see that actually the autoencoder is picking up and learning to encode the day of the month in the latent space, which is a signal that this might be a relevant feature for it to reconstruct, which would make sense. If we then continue, you see that there's the same type of clustering if you go by week number. So here I took a very small validation set with only a few weeks, but you can see clear clustering. And keep in mind, Testi is created to, as much as possible, keep the distance relationship the same when you are reducing dimensions. So I think the clustering is rather decent here. I also have a bad example for you. This is the clustering produced on the hour feature on the same validation set. So this looks completely random. If all of my plots would have looked like this, I think the conclusion would be that the autoencoder is simply not learning anything. But I think in our case, there is a qualitative assessment that there is some learning taking place. Whether or not this is going to be enough to detect the bankruns, we don't know yet. As I said, it's work in progress, but at least it shows some promise for the methods. Let's see. So that is also the conclusion I can give to you, is that the autoencoder seems to be learning, and we're really in the middle of the project, but it does show some promise. And hopefully we can, once the paper has been released, we can report the impact of memory on this learning process. And once we have done the full complete run on our target 2 data, we will also do the same exact sequence of operations on the Canadian payment system, which will be very interesting to see whether there will be similar results. And we also plan to use our autoencoder with the weights we have produced with training on their data to see if it's actually generalizable. To be fair, I don't expect that to be generalizable, and I expect that they have to retrain to get some results, but it's going to be an interesting comparison, I think. And then we have one of the greatest philosophers of all times, I think, the Terminator, warning us for artificial intelligence. But so far in our project, it's more like this, where our AI is learning something, but we are unsure currently whether we have really a good detector in our hands. So this was a short overview of the project. If there's any questions or remarks, I would love to respond.
Thank you very much, Timothy. And I said, don't press this stop presenting button. So, but then I can take maybe the control back to Helsinki. And now we have time for a few questions or comments if there are any. So please raise the hand and pose your question, or if your Canadian colleagues would like to add something on this.
I'm not sure. I don't see any questions like this.
Matti, maybe you can pose the question.
Yes, maybe I can take the floor if there are other questions still coming. But I found it very interesting, and one question just to throw to you now. You had there the picture about in the motivation about the airplanes, the cockpit.
Yeah.
How it has so many monitors and it measures this and that, and it's important information for the pilot. The difference maybe here is that we might define many indicators, but what are then the controls? I mean, the cockpit also has many buttons and levers and things they can do.
So
what would be the levers? What would be the actions?
So I think the proposal here is that if the autoencoder is able to encode the regular payments and then detect the outliers, right? You remove a lot of the features and a lot of the levers and controls. You would basically have this in an automated pipeline, checking all of the transactions coming through or checking several windows of the transactions coming through. It's up to and it would generate a signal. There would of course be a new problem with false positives or in that signal. I mean, you would prefer false positives over false negatives, and you would then need to check every signal. But I think this method, if you have it included in a pipeline, would actually reduce the amount of levers you need to control, because the autoencoder is supposed to teach itself which features are important and which features determine what a regular transaction is. Does that answer your question?
Yeah, in a sense, but somehow, I mean, if a pilot notices that the plane is about to crash, he or she will pull the lever and direct the course differently. But I mean, okay, here you are saying and explaining that it's to detect bank runs, and then that guides the thinking a bit. But
so the thing is, of course, then to act on the signal if there would be a bank run, that is really out of the scope of the algorithm itself. But there is some feedback possible in the algo, right? So I mean, in general, if you would have the algorithm running in the pipeline, you would have some sort of a feedback loop where all of the signals are collected, and you would have human interaction, basically labeling each signal, whether it was a true positive or a false positive, which could then be used to retrain the algorithm on a concurrent basis, on a continuous basis, to improve. But as far as the real world implication, I mean, if you would have an early detection of a bank run or liquidity issues, the algorithm, of course, has no way to intervene. That would really be up to the supervisors.
Yeah, of course.
Okay. Any other questions or comments? We have few minutes. Okay, so we can still, after the final presentation, we can of course come back to any of these presentations if you still have any questions. But maybe we will move on, and the last presentation today is by Martin Diehl, Programmable money options for central bank. And although it's last, it's not least, I would say so. And Martin, now I will give floor to you, and you can take the control and give your presentation. Please, Martin.
So, thanks very much. First, can you hear me? Anyone?
Yes, I can hear you.
Wonderful.
Very well.
Good. At least you, Tatu, that's good.
Yes.
I think all the others are muted. Thanks very much for organizing this conference and keeping up the tradition. I'm very happy to be in touch again with you. It's good to stay in contact in these times, not only because of Corona. We all feel that the international cooperation is undergoing some particular pressure. And we as scientists should stay at the forefront of those who seek international exchange and cooperation. A virtual seminar, of course, is not the same as having a personal meeting, but let me try to remind us what we miss. So, only one of the valuable parts of the simulator seminar, of course, is undoubtedly the sauna experience. It has already been mentioned. Look at this Finnish commemorative coin of 2018. It depicts a typical Finnish landscape, a big lake, a lot of wood, and a smoking sauna at the shore of the lake. Beautiful, isn't it? If you look closer, you discover 3 smoking saunas. Indeed, Finland has much more saunas than lakes. So, but I wondered about the 3, and the only possible reason I came up was it is to honor Tatu, Matti, and Kasperi at the same time. Anyway, I show you this coin to point to the fact that money has many features. Some of the features of a coin are described here. Since it is a commemorative coin, the description focuses mainly on the physical aspects. These aspects are also important to recognize counterfeit coins. As economists and central bankers, however, we consider the most important aspects of money those which contribute to the use of it. Money is what money is used for. A coin which is not used for payment does not, or not used for storage, or not used for as an accounting unit. This is not money. And from our retail studies, we know that the most important features of money are stability in value, safety, convenience, simplicity, confidentiality, and sometimes anonymity. Well, I agree, of course, with confidentiality, which means besides that the payer and the payee, no other person besides the intermediaries should have knowledge about a payment. However, anonymity is for the sake of anti-money laundering and fighting terrorism should be limited. We still support cash, and we do not think that every user of cash is a criminal. However, I would not buy the arguments that cash does not contribute to illegal activity. That sounds too much like the argument of the National Rifle Association that automatic weapons do not contribute to murder and shooting. The plurality of features and the manifold features we have with money, even in the simple form of a coin, leads me to the conclusion that potentially more complex feature or more complex form of money has many more features we have to look at, especially if we talk about so-called programmable money. The literature about digital money, about tokens, crypto tokens, stable coin, and CBDC, central bank digital currency, is exploding. Almost every important central bank in the world has published more than once about it only this year, let alone the universities and academia. Almost every working group or committee in the Eurosystem has discussed it and drafted various comments on related papers or terms of reference. We have a vast and fast growing literature on how to design digital money or programmable money. Very little, however, is stated about the purpose of digital money. And I must confess that we in Germany, in the Bundesbank, also entered the debate in that way. We avoided somehow the question why and started discussing the question how. That was easier because it does in the first place not require an opinion formation. We do not have to make up our mind whether we want it or not. We just discussed how it could look like. And at some point it became a self-moving discussion because everyone else discussed it, especially those who had already made up their mind to issue digital money. But unfortunately, the question how requires an answer, a prior answer to the question why. We need to know what the purpose of digital money is in order to design it properly. Which is the decisive feature we do want digital money to have? What use cases do we want to serve? What customers do we have in mind? Unless we state what our objective is, we cannot possibly agree upon a design. Digital money has been termed first by some proponents of blockchain or distributed ledger technology, though the origin is somehow technology-based and has to do with decentralized networks. The blockchain community, let alone the Bitcoin community, however, never intended to support any money issued by a bank or a central bank. Intermediaries and central institutions were, in their concept, deemed to vanish. Well, after many discussions and refinements of the concept of crypto assets, we know better now. The proof was given by the community itself in putting emphasis on creating stable coins, which derive their stability from the backing in real currency. The community conceded the superiority of central banks when it comes to creating stable money. So we know that the feature stability is of utmost importance. And obviously the euro and the US dollar are perceived to be stable. But what is the decisive difference for a so-called digital money? Well, to find out, we can look at the market participant and ask them, which use cases do they think of for using digital money? In the blue field, you can find a list of use cases named by financial institutions as well as non-banks from the real economy when asking what they would use digital money for. M2M payments, IoT, Internet of Things payments, of course. The difference is that here we have an interaction with the customer. Then all kinds of payments related to a smart contract, either the smart contract as a controlling unit, which triggers the payment, or the smart contract as a trustee. Pay-per-use, if could be linked to machines as well, or so-called bi-directional settlement. If you have two companies having 300 to 400 payments to each other on every day for various deliveries, they were looking for something where they could settle it better than by a traditional payment system. They were asking for digital money. Cross-currency or cross-border payments are very often called to be improved, to be enhanced in efficiency by digital money. 24/7 payments. Well, I must confess the opening hours of current payment systems are somehow restrictive. We all know that, and most of us know that it would take some time and a lot of effort to improve that, but we are on our way. And then the idea that payments would transport and transform more information, the integration of payment and communication systems. With digital money, it might be easier. The different use cases are not disjunct or exclusive. Of course, sometimes they apply together. Payments for pay-per-use could also be M2M payments as well. Or IoT payments could also be triggered by a smart contract. Some of those use cases, however, are not technology-driven. For instance, 24/7 payments is merely an organizational aspect. If we widen the opening hours of our payment system, people would see no 24/7 use for digital money. Maybe instant payment could do the trick here. The red box depicts the two non-cases in my mind. There may be more. Unfortunately, non-cases which are quoted very often. Some argue that the declining use of cash might be an argument to issue a substitute. So that people don't want to use cash anymore, and therefore we need to issue better cash. I do not quite get the logic. The people will only use the substitute if it bears some superior features. And that's exactly what we have to find out. What is the superior feature we need to implement into digital money in order to make the people using this instead of cash, which they don't use anymore, or not so much as some perceive it proper. Second case is facilitating monetary policy. Well, if we had wanted to grant access to central bank money for everyone, we could have done so. This does not depend on any digital features. This discussion is coming from the mid-30s of the last century, but we decided otherwise. And relieving the lower bound of interest rates requires mainly the substitution of cash, but this is supposedly not the objective, at least not in the euro system. So facilitating monetary policy is not a quite convincing case for digital money, as I see it. The gray box depicts two cases which might turn out to be somehow propelling and compelling even and imperative. If other central banks issue digital money, or if a private stable coin penetrates the market, these aspects could become reasons to act quickly, although these cases do also not answer why we should issue digital money in the first place. That's why I focus on the technological aspect, because the whole discussion is coming from the technological invention of blockchain and DLT. What could be done here to improve our payment system? Looking to this slide, I would like to give an example of the smart contract to explain what we could think of as programmable money. There are other cases. It does not have to be a smart contract. The point is that money should serve a more function in a way that it could be coded and used in a coded form by the consumers. Let's assume we have a buyer and a seller, and they have a contract that fish is to be delivered against payment. The condition is clear. It should be shipped to a harbor, and it should be always been frozen, or not frozen. It should be permanently below 2 degrees Celsius. Okay, the whole contract is now coded in a smart contract. The smart contract receives an asset token by the seller, which represents the fish. And the buyer would send a payment token. Now, the smart contract receives those tokens and checks the fulfillment of conditions. If all the conditions are met, it would transfer the payment token to the seller and the asset token to the buyer. If the conditions are not met, it would return payment token to the buyer and the asset token to the seller. So the smart contract is only a code which reflects the contract and all defined conditions and criteria. Now we have two outside entities, a harbor master. The harbor master is supposedly reporting the arrival of a sealed container in the harbor. And we have temperature sensors in the container. And the temperature sensors would measure and report every 5 minutes, for instance, the temperature to the smart contract. So the smart contract would realize, okay, fish has arrived. Fish has been always below 2 degrees Celsius. So now let's fulfill the contract, transfer the tokens. Otherwise, the smart contract would return the tokens. That's that. So digital money in this way is programmable money that you could use the money for within a smart contract. That is, for me, one of the decisive features which we should enable in the future in order to make use of this new technology, something which money today cannot achieve. Now, what forms of money do we have in order to supply the public with digital money? Well, we started out in that community with crypto token, but they are so volatile that no one really uses them. The next idea was stable coin. Okay, stable coin are still usually not a claim or a questionable claim, and they are only commercial bank money. Next aspect would be digital commercial bank money. I still have listed here the JP Morgan coin, but I learned yesterday that the JP Morgan code of quorum was sold to Consensus. So I guess JP Morgan is not pursuing that. I don't know. This is commercial bank money, and it would be a claim on commercial bank. Then we have the idea of a so-called trigger solution, which I will explain one slide further. Trigger solution is somehow a connection between a smart contract or a DLT to our conventional payment system. It could be to an automatic, could run to an automatic clearinghouse. It could also run to an RTGS. In the latter case, it would be central bank money. In the former case, commercial bank money. And then we have two other forms: stablecoins backed in central bank money, which is non-existent today as of today, but there are proposals to do so. And then the last form is CBDC, which is widely discussed, and all of you have heard about it. Clearly, this would be the highest form, would be central bank money in its simply in another form than cash or claims on target 2. So what do I mean with trigger solution? Trigger solution is something we are working on in a little experiment in Germany in the Bundesbank together with partners. Think of a DLT, a private DLT, a private blockchain. Then we have two corporations and they set up a treaty like the one I explained about the fish delivery, and the treaty is coded in a smart contract. But instead of using a token, tokenized money, this smart contract triggers only a payment instruction via somehow an interoperability mechanism, which is depicted in the gray field here. And this mechanism links the private blockchain to a trigger chain, as we call it, which is run by the Bundesbank. And on both blockchains, you have the banks participating, though the banks, Bank B is the bank of Corporation Y, and Bank A is the bank of Corporation X. And they know about this smart contract. They receive payment instruction by the buyer, and they send the payment instruction to the Bundesbank, which reads it automatically in the trigger chain, further sends it to target 2, and sends back a payment confirmation that the payment has been sent from Bank A to Bank B in target 2 after it is really settled. So this signed payment confirmation goes back to the smart contract, and the smart contract in the end sends the asset token to the buyer. If the confirmation does not come, or if it is rejected and the Bundesbank would not sign it or send payment has failed, the asset token would be returned to the seller. If we manage such process, such a technological bridge between DLT and target 2 within a few seconds, we could probably grant something which we could call programmable money. We could make that the corporations use DLT for their settlement, that the money is settled in central bank money between the banks without having created digital central bank money, without creating a token. Only thing we create is a token, it's a tokenized form of a payment confirmation. The arguments for the trigger solutions are pretty simple. Well, first, the technological innovations are facilitated because we help the companies using DLT, be it for M2M payments, IoT, or whatsoever, without granting access to central bank money for non-banks. So we don't have to change anything. No implications for monetary policy, for financial stability, or for payment services. We can use the existing infrastructure and all the applied regulation. The chain could be made neutral towards all techniques. The only aspect is we have to adjust the interoperability mechanism according to what technique is used, whether one uses Corda or Hyperledger or whatever technique in its corporate chain. This is their business. We could adjust to that. Only the trigger chain is run by us, and we decide what it is, and we link it to target 2. Not to target 2 directly, but to the same instruments today, which are used today to address target 2, like Swift or Internet. The implementation is much easier than creating central bank money, digital central bank money. I think we could implement it within a year at low cost because we need only this access mechanism. The constraint, of course, is clear. The operating hour of target 2 are a little constrained here. A little solution could be provided by TIPS because it had longer opening hours. So my point here is, when talking about options for central banks in programmable money, that we have many options in our world. The realm, there's missing M, sorry, the realm of central banks does not necessarily have to be widened into the field of commercial banks. We could stay within our realm, only providing central bank money. We could have still the whole liquidity management in target 2. So we have only one account for the banks where they manage their liquidity. Unlike wholesale token, where you split up the liquidity, where banks have a token they have to watch, they have still their T2 account and maybe also their TIPS account to watch. This would still here be on one account. Some of the options for central bank money, for programmable money, could be implemented very fast at low cost and without much risk. For me, digital central bank money, what we all discuss about in various groups, it's not risk-free, it's not easy to issue. It could be at the end, but we could much farther with such a solution of trigger chain and help the industry for using DLT, for using modern technology in order to facilitate innovations here. Thank you very much. I'm looking for questions.
Thank you very much, Martin. It was very interesting talk what you had, and now you can ask questions. There is Timothy. You have one question. You can unmute yourself and then pose your question.
Yes, thanks. Thank you first of all for the presentation. I have a question which is twofold. First part of the question is, do you think a DLT is necessary for smart contracts? And the second part of the question is, if a DLT would be needed, why the double chain concept? And why is it not possible to simply have a target representation account inside of the DLT?
For the first question, it would require me to be more technical oriented guy than I am. I have learned that we could think of programmable money which is not designed by a DLT, which is not bound to a so-called smart contract. Point is for me that we should try to be as technological neutral as possible in order to facilitate other developments beyond TLT. There are also already technological firms thinking beyond. Indeed, the second question, we have thought about it, whether we should just simply create an API or not. The point is here that we think if we require our partner banks who are members in the Target 2 Bundesbank component, which have an account with us in Target 2, to run a node on a chain, we could create the ultimate level of trust here. And everyone who wants to access Target 2 by other devices than today, where something like a payment instruction is stemming out of whatever technology, that should be entered by one and the same technology. Everything should run through that trigger chain we have here. This was our idea. We simply thought an API would not grant this level of trust. So we think that the banks would possibly in the future be partners on many private or corporate chains. Could be one of the stock exchange, could be one for trade and so on. And all of them would be linked to us. But we have only this limited amount of partners which have already an account with us. And if this payment instruction is signed by them, they see it already. So the two banks involved would see it, the payment instruction, and we as Bundesbank would see it. And so we could create this level of trust necessary for creating this A2A mechanism. That's basically what it is. Yeah, I could think of other solutions, but we are at the moment we focus on in this way. Maybe it could run cheaper. We have not done any performance checks, how fast it is, but our technicians believe that it could run within a few seconds. And let me add one more thing. There are people who argue that we would not be able to settle those many little payments if, for instance, those fast payments where when you think of a token today, let's say you have a car and you want a pay-per-use payment. The car is standing at the traffic light, and while the traffic light is yellow and red, it refills his battery by the induction curve in the street, and after a few seconds, like 35 seconds, the light turns green and the car is moving away, and so the electricity has to be paid immediately. Of course, we could think of a lot of pay-per-use cases which has to be settled very fast. However, as I mentioned, there are many forms of programmable money. I could think of in these cases that in this case, it is first settled in commercial bank money. And then people would sometimes they argue, no, but commercial bank money is not as safe. Yes, but filling up a battery would not cost more than 100 euro or 200 or 250. For 250 euro, we could still use commercial bank money. And if after half an hour at this traffic light, the budget has been run up to 2 million, of course, then we could put in a settlement cycle and they could finally settle it via a trigger solution. So we think of a combination of those programmable money, forms of programmable money in the future.
Okay, thank you, Martin. I had a question that we have international audience here, so have anybody from the audience any experience what you would like to share with us concerning this topic?
There are questions in the discussion in the chat also, so you can, Martin, maybe have a look on those.
Okay.
If you can, Matti.
Yeah, no, I see that. Sorry, I had not had a look on that. That's the first question. What is the risk of central bank digital money and how to mitigate the risk? Yeah, first we don't know. The biggest risk would stem, in my eye, from the fact that central bank digital money would substitute for deposits bank, because large deposits with banks are not safe, are not covered by the deposit insurance, and if people have the chance to keep their transaction balance in central bank money, which they don't have today. Only banks have access to central bank money, unless you talk about cash. Then they would change their behavior and maybe hold only central bank money. So this would change the banking system. It would change the business cases for many banks. And actually, we don't exactly know what that means for monetary policy and for financial stability. The case is not that we want to save the banks in their current form today. The case is we want to understand what will be with the future of banking business and of financial stability. The next question: is settlement finality achieved at the same logical second as the contractual obligations are fulfilled? Well, it depends on the time, how long it takes. At least we think that we could almost achieve a DVP within a few seconds. It is not at the logical same second, but I think we could resemble a DVP as much as we achieve it with T2S. Target 2 security, sorry. Yeah, what about the retail CBDC, the Riksbank? We're very interested in that pilot project of the Riksbank, the e-krona. First, as far as I understand, it doesn't have to do much with distributed ledger technology or with blockchain. It's not clear what the case will be. I think it is more motivated by competition policy, that they want to give an alternative to the Swedish people. But I hope maybe there are some Swedish experts here who could talk about that. Yeah, and then Jussi was asking if government in the Eurozone decided to use helicopter money, for example, to tackle the financial problems of COVID-19, would CBDC to be suitable tool for this? Well, if every single person in Europe has access to CBDC in the same way, it might be possible. I think in terms of simplicity and usage, still cash would be the ultimate choice, ultimate tool of choice if we want to use helicopter money in the near future. CBDC must be as easy as using a phone in order to be able to become something, a tool for helicopter money, and we are far from that, very far from that.
Okay, how about you, Matti? Have you?
Yeah, I just thought if I may challenge you a bit, Martin, since remembering the basic functions of money. So there's store of value, as unit of account, as medium of exchange. I somehow don't recognize there being a programming language. So my point is that why do you think it's desirable to include programmability into the fabric of money? We do have tremendous capabilities in the information processing side for programmability, and wouldn't it not be better to keep that just there?
Well, we have a very powerful tool at hand with DLT, distributed ledger technology, which is supposed to be able to reduce the complexity in many branches and many industries, especially logistical problems could be solved much easier. The complex settlement in our world, which is mainly driven by labor sharing, the complexity could be reduced very much. And but we have to provide something to them which also serves as a money leg. Only exchanging goods faster and recording it faster or more safely is not the trick. They usually also want to have some sort of payment for this, and therefore it is not enough just to have an account. Usually they need to include it in the process to be automatically used. That also brings me to the case that retail CBDC should not be at the front to be discussed by us. Here I'm talking really about M2M. Like think about a robot is cleaning a factory, and the cleaning of the factory is checked by the owner of the factory via a drone which flies through the factory and looks in at each corner whether the robot has done a good job. And then the drone will report to the owner of the factory, well, everything is clean, you could pay the other company which owns the robot. And here, the step is missing that the drone directly pays digital money to the robot. This could speed up this process very much, that we have an integration of those processes of delivery, of payment, of all exchanges. So companies are looking for something where they could include the money leg. They have now so close interaction. Industry 4.0 is one of the keywords, the buzzwords here, very often used. But they are missing this money leg. So I really believe that we need programmable money in some form.
Okay, Kasperi, you maybe can have the last chance to make a question.
Okay. there was actually two things came to my mind. The last one was interesting from this point of view, that whether actually depending a little bit how, if you have a money token which is also a contract, and these two are like tied together, I think there might be a bit of a risk of actually some sort of that it will raise liquidity cost, because if as a company you tie some of your liquidity resources to a token, or if this token is even itself money in this sense, and you tie it to a contract, then this contractual money is tied to a system. It's put on hold until the delivery of the goods. So I think this might actually increase consumption of liquidity. At least I see some risk depending a little bit on the arrangements. And I have another comment that this triggered solution is actually very pleasing to me in a certain sense. And but I see that we already have some elements existing that are already in that way. You mentioned yourself already DVP, so security settlement systems, and another that comes to my mind is actually CCPs. And you have future contracts there that the contracts are stored in the CCP to be executed later. And so indeed, in this triggered solution, we have some kind of examples already existing, in my opinion. And the thing is that we kind of maybe would need more like a more generalistic kind of clearinghouse that you can store these contracts there, but without necessarily tying money or tokens there, but just store the contracts. And in these smart contracts, you would have, of course, the claims and the conditions, the kind of DVP conditions that can be much more complex, like in your example, than just a pure DVP in the traditional sense. But indeed, also in the how do you say, in the mood of PSD2, that's this ACH or new type of more generalistic clearinghouse that would maybe be able to clear also goods and stuff like that, will be initiating the payments in the classical systems in a way, like you said, actually yourself too. And but then like there was the question of the finality, and if it's achieved this DVP and with lag or not, then I think if we are using some sort of payment initiation services or account information services, we need reservations on the accounts. So when you start doing this DVP, just like in the security settlement systems, I think we need to be able in the settlement process to make block these goods in the ledgers where they are stored and where they are supposed to be settled. Thank you.
Okay, Martin, maybe you can shortly reply. It was a long question.
It was a long question, but it was worth listening because Kasperi is a truly expert. Kasperi, you're absolutely right. Creating a token like digital central bank money or any other token would split up liquidity. That was one of my points. If we have a trigger solution, we would keep the liquidity on one account, which is not only easier to manage, but still would save liquidity. I know nowadays we don't worry about liquidity because we are flooding the market with liquidity. But I'm from somehow I'm old school, and I believe normal times will come back at some day, and liquidity. We will understand that good money is only when it is scarce and when liquidity is scarce. So we need also liquidity saving mechanism in the future. Maybe not the next 5 years, but someday. Second point, yes, T2S is one of those features where I thought of. In T2S, we have somehow a trigger solution where we keep the money on one account in T2 and have a directly link between a settlement system, in this case, a security settlement system, and T2. However, we cannot set up settlement system for all goods in the world. We cannot set up a chemical settlement system or a logistic or for cars, for vehicles, for whatever, and put it all on our central bank account. The industry will set up their own settlement system, but they need a link to a money lag. and they want to have it directly connected, ideally, if these are large sums involved, to central bank money. And for that, we need to trigger chain. The logic is exactly the same as you explained it, Kasperi. Thanks very much.
Okay, thank you very much, Martin. It was very inspiring presentation, and now we are getting closer of this seminar. Usually at this time, I would give you guidance how to go to marketplace and take a boat cruising to Bank's Villa, where we would have like this, these three famous SS, like sauna, swimming, and salmon, like we have had over many years. But let's hope that next year we can do this as a physical meeting. And now the closing of the seminar, Jussi Terho will give that for us.
Okay, thank you. Yeah, it's time to close the webinar. First, I'd like to thank our speakers for their very interesting presentations. I also want to thank the audience for participation and for those good questions asked, even though the time that was available for discussions was very limited. So thank you very much. And I'm extremely pleased that there were so many of you online. And last but not least, I want to thank the Bank of Finland team for organizing the webinar. So thank you, everybody. Like already mentioned in the beginning, this was the 18th time we organized this seminar. Originally, the plan was to have this back-to-back with the 10th Economics of Payments seminar in Helsinki. As we know, things had to be reconsidered already in the spring, and the Economics of Payments seminar was rescheduled to take place next year. At the moment, our plan is to organize both the Economics of Payments seminar and the 19th simulator seminar back-to-back in Helsinki next year. I wish to see as many of you as possible there in person. A very good source of information regarding these events is our simulator mailing list. If you think you are not on the list, please go to our webpage right away and register. The link is here, the upper one. And one more thing, the employees of the Bank of Finland write blogs on bank's site, bothbulletin.fi, every now and then. Often the texts are only in Finnish, but this time Kasperi wrote a blog about simulator in English. Please check that out and ask your colleagues and perhaps your manager to read that too. Have a good rest of the day, and thank you, and see you next year, hopefully in Helsinki.
Okay, also thank you from my side. It was nice to meet you in web, and hopefully see you next year in Helsinki.